All right, this is a video on how to solve radical equations. Before we get started, be prepared to take great notes. So make sure you have paper, something to write with, and pause as often if you need to. If you have any questions about something that I did in these examples, take a screenshot of it or take a snapshot of it and just send me an email. All right, so what is a radical equation anyway? It is an equation with a radical expression on one or both sides of the equations. Now, here are some examples. A couple of these have radical expressions on both sides of the equations. As you can see, they're not all square roots. A couple of these are cube roots. And although we're not going to, at this time, solve anything other than square root or cube root equations, you could, using these exact same steps, solve any kind of radical equation. For example, something to the fifth root. Okay, so let's get right into it. Here is your first example. The first step is to isolate the radical. In other words, we want the radical expression all by itself, not even a negative sign, nothing outside of the radical on one side of the equation. So we're going to add 4 to both sides and then divide both sides by 2. And we end up with the square root of x minus 7 is equal to 7. At this point, we can go to our second step, which is to raise both sides of the equation to the appropriate power. Now, what is the appropriate power? That depends on what kind of radical you have. We have a square root, so we're going to raise both sides to the second power because it's a square root, and that's how you cancel out a square root. You square it. So when we square the square root of x minus 7, we end up with just x minus 7. You notice it didn't change the expression x minus 7 in any way. In other words, I don't have an x squared and I don't have a 49 because all I'm doing is canceling out the square root. And on the other side, when I square 7, I end up with 49. All right, so let's go on. And now we're going to solve for our variable. So we're going to add 7 to both sides, and we end up with x is equal to 56. Now there is one more step. I didn't write it as a step. I'm just going to give you this reminder on every example. Always, always, always check your answer by plugging it back into the original equation, because it's possible that you have an extraneous solution, a solution that doesn't work. In other words, it's possible that this equation has no solutions. So always check. Here's the second example. This one is a cube root. And you also notice that we have radicals on both sides of the equal sign. So there's nothing we need to do to isolate. In fact, this one is as isolated as it can possibly be already. Now, I could divide both sides by 2, but what's the point? Then I just have 1/2 times the cube root of x plus 7 on the other side. I'd rather stick with the 2. So that brings me right to step 2, where I'm going to raise both sides to the appropriate power. And in that case, the appropriate power is 3 because this is a cube root. All right, I see that I have a typo right here. This should have a little 3 there. So make sure that you do that in your notes. Now, the one thing I want you to notice, when I cube both sides, I cube the coefficient of 2 as well. I have to cube everything on both sides. That includes that coefficient of 2. Now, 2 raised to the third power is 8. So I end up with 8 times the expression x minus 1. And on the other side, I've canceled out my cube root, so I just have x plus 7. Now I'm going to solve for x. To do that, I'm going to distribute the 8. I end up with 8x minus 8. I'm going to subtract x from both sides and add 8 to both sides. That gets me 7x is equal to 15. And my answer is x is equal to 15 over 7. Now remember, I said to always check your answer. This one I've already checked and it works. Now here's our last example. Here, we're going to end up with a variable on both sides of the equation. So I have to isolate the radical, so I'm going to subtract x from both sides, and I end up with the square root of x plus 3 is equal to negative x minus 1. So I don't have a radical on both sides, but I do have a variable on both sides. Well, what's up with that? It looks a little bit different, but I'm going to ask you to trust the process. And the process says that our next step is to raise both sides to the appropriate power, which in this case is 2, because it is a square root. So I get rid of the radical on the left side of the equation and end up with x plus 3. And when I square negative x minus 1, remember, I have to distribute. So I don't get x plus 1 or x squared plus 1. I have to distribute, or some of you know that as FOIL. So I get x squared plus 2x plus 1. Now this point that you have to distribute or otherwise FOIL is very important. If you don't know how to do that, go Google foiling binomials. FOIL binomials, and you will find the method. All right, so now that I'm here, I get to step 3, which is to solve for x. So, I have a quadratic, x squared plus 2x plus 1. To solve quadratics, I need everything on one side of the equation equal to 0. So I'm going to subtract x and subtract 3 on both sides of the equation. That gets me to 0 is equal to this quadratic, x squared plus x minus 2. Now, in these kinds of problems, if we gave them to you, we really don't want you to spend time using the quadratic formula if you don't have to. So if we gave you a problem, it's probably factorable. I factored this, has 2 factors, x plus 1 times x minus 1. Now I can take each one of those, set them equal to 0, and solve. So x plus 2 equal to 0, x is going to be equal to negative 2. And x minus 1 equals 0, x is going to be equal to 1. Now you remember I told you how important it was to make sure that you check all of your answers? Well, if I go back and substitute negative 2 back into the original equation, it works. It's going to be equal to negative 1. But when I go back and substitute 1 back into the original equation, no matter what I do, it's never going to be equal to negative 1. That is a solution that does not work. We call those extraneous solutions. I'm sure you remember us talking about those in class, but if not, go look up extraneous solutions. At this point, you should have detailed notes with 3 examples that really cover most of the kinds of problems you will ever see in this particular space on radical equations. You should be able to, using your notes, show evidence of learning how to solve radical equations with radicals on one or both sides of the equation, and You should be checking. So you should be able to identify extraneous solutions. Now, at some point, I'm going to ask you to do just a very few problems, probably one of each type, and upload it in the Google Classroom as evidence that you know how to do this. Now, if you're not sure you know how to do this, then, or at least you're not sure you have good notes, watch the video again, pause frequently, and make sure that you understand each step and have great notes, because you're going to be able to use your notes on your retakes. If you have any questions at all about something I did in a problem, take a snapshot of it or a screenshot of it and email me with your question. Later, folks.